name's Wayne Harttman. If anybody wants to get in touch with me after this, you may or may not. There's my contact information. It did make it out on some of the handouts, and we'll have some more for people who want them afterwards. Here's what we'd like to talk about today. Utility demand response, and that's really a very big subject in about the past 5-10 years, and getting more so every day. We're going to look at distributed generation and how it kind of dovetails into a demand response effort, both at a utility level and at a facility level. Then we're going to look at interactive distributed generation. That's really the basis for the remote operations management. If you can't be interactive with this and be able to aggregate and get this on and offline quickly and wide scale, it won't serve its purpose. The demand response windows are often very short. Typically they can last an hour, be even less, sometimes up to 2 hours. That's really where these critical peaks are in power system demand. Then we'll look at why employ the IDG. Right now, most people, if you said, what's demand response? Turn it off. You wouldn't say, turn on a generator. It's almost counterintuitive. But if you can remove load locally, that's why you want to go and do it. Then we'll look at how the remote operations management, how that dovetails in and makes these systems operate. When we look at utility demand response, really what we're trying to respond to is other power emergencies, deficit of megawatt, deficit of VAR. You can start to sag lines and have transmission instability. If you want to see a good example of too much demand on a system, the Northeast blackout, 50 million people in the dark, that's too much demand and there wasn't enough supply both in watt and VAR to handle it. Then you have response to market prices. Peak power costs money. If Florida Power Corp or now Progress Florida runs out of power and they have to buy it from Georgia Power, there's no such thing as price gouging protection. Sock it to you at demand time. You can go up to very high levels of dollars per kilowatt or dollars per megawatt. So there's a big financial incentive, and guess what? For facilities, that gets passed on to you, and we'll discuss that in a little bit. You relieve load how many ways? There's load management, you peak shave, you do complete load curtailment, you just turn things off, like in homes, they turn off hot water heaters and that on the domestic level. And conservation voltage reduction, a nice way to get some demand response. If you lower the voltage, you lower the amps consumed in most devices, and therefore you can lower the watts. How does DG, or distributed generation, use for DR? We relieve the load locally. So if we look at load on a utility and we look at that as a facility, if a facility has generation and you turn it on, you can relieve the load locally. As far as the utility is concerned, you turn something off. The meter's spinning slower, so to speak. You have relieved the load. That's called negawatting. That's kind of a terminology that we've been using when we speak with utilities and heavy power consumers. It affords the ability to negawatt with your on-site generation. DG can be applied seamlessly. Now, some of you who may be familiar with your facilities with backup generation or on-site power, there's a transfer switch, and the thing goes clunk. And when it goes clunk, you have an outage. It might be a short one, but that upsets your processes and upsets your motors. There are ways to make this seamless, the way it transfers back and forth, loads and reloads and unloads, and we'll discuss that and show you some diagrams of how they actually work. If done properly, you wouldn't even know it's happening. In a facility, you wouldn't even see a blink. Your power quality meters wouldn't see a deviation in voltage. All the utility would see is the power consumption go down, and you as a facility would see money go in your pocket due to the rate structures that are involved around demand response. Here's a cartoon picture of this one. Here's a simple one. On the left is your facility. It consumes 500 kW and it's coming in off the line. You turn on a distributed generator if you could seamlessly connect it up, and you can relieve almost all the load. In some cases you can export, but this shows that you're still importing a little bit from the utility. So when we look at IDG, that's making it interactive. That's where the I's all about. Typical size, 250 kilowatt to about 5 megawatt. Yes, there are bigger data centers, and yes, there are small emergency power generators. But a sweet spot to apply this in industry is around the 250 kW to about the 5 meg, sometimes the 10 meg size. And reason, a lot of facilities are connected on distribution. Distribution lines don't typically go higher than 10 or 15 megawatt. You're not going to have a 50 megawatt cogen plant in a chemical factory or some large facility that's hooked up to a 13 kV line. You're just going to get that much across the line. So the eye does two things for us. Lets us turn it on and off remotely, lets us monitor it, and with that turning on and off remotely, even lets us test it remotely, which is a neat thing to do for reliability. Here's a typical system. You'll see the transformer, the pad-mounted transformer on the left. You'll see a gray box with switchgear. We'll put that in quotes because we're going to discuss what's in there. And then you have the generator in various shapes and forms. For this illustration, we're showing a single generator and a single piece of switchgear to go and get the job done. And if you had a bigger system, multiply the numbers and have more generators and more breakers and more gear. Why employ this in the first place? Peak management, you can defer as a utility T&D build out. The utility doesn't own the asset, which is really big now for utilities when they're talking about cap and trade and carbon penalties. If the utility doesn't own it, they don't get kicked for it, and typically some of these facilities are so small they go under the radar in megawatts or in kilowatts, so they don't get hit by it. C&I customer programs, if you're a C&I type utility customer, which most of these facilities in this room would be, you can get rate incentives, critical peaking power pricing, and other types of demand response programs, and it's especially effective for those who don't have load to turn off. If you're a hospital, I can't turn half the hospital off. If I'm a water plant and I need X amount of gallon throughput and X amount of horsepower on the motors, I can't say, well, let's turn off half today. We're going to have trouble. So think of critical industries 24/7 critical. This is where it's used. It's dispatchable by the utility. That's key. If the utility can't dispatch it, you can't get it out when the utility needs it, then take advantage of the pricing and the rates. Harvesting, we're taking, you know how many gigawatts of this stuff is on the ground? When you go behind every hotel that's out here on International Drive and every wastewater plant and every hospital and every data center and every wafer fab plant, there is so much generation on the ground and not much is being used for this. Statistically, it's a few percent tops. So there's a lot, and we call it harvesting. It's your boots are already on the ground, your iron's on the ground, put some brains on it, and you've got something that can be used and avoid huge construction and huge infrastructure costs. Meeting the future. Everybody wants electric vehicles, and yeah, wait until you put 300 of them out on a line and you start overloading everything, the transformers, the distribution transformers, so you can meet the future with this. I got to talk about sustainability because somebody's going to say, hey, wait, you light up that big yellow generator and a big black cloud comes out. How does that help us out with sustainability? One of the key reasons, a big reason, or probably the biggest, when you take a facility and you power it up locally, like we show here, the line losses go away. To transport power from a bulk utility asset, like over here we have Orlando Utilities Commission and Florida Power and Light, if there's a gas turbine plant that's 100 megawatts and it's 30 miles away, you're losing anywhere from 3 to 7% just to get it here. If I take the same efficiency and I light it off locally, I lose that 7% loss. So everything blows a little smoke and makes a little carbon. The question is, can you get rid of those losses? So a big thing right away for sustainability is the losses. You can precisely match it. When you want to use DG, you may want to use it in certain areas where there is a constraint, not all over the system. So you can be very granular would be the word for that. It can be started and fully loaded in 10 seconds. Incident took place. It was in southern Florida. They lost about 3,000 megawatts. There was an incident on transmission and it tripped out generation. We were able to dispatch 200 megawatts in about 20 seconds into South Florida to help the grid stay together. That's how fast you can start this stuff. Hospitals have a requirement, 10 seconds. Otherwise, people aren't hanging around too long. You have to get this up. So the smaller generation can be started and stopped multiple times an hour and exactly as needed. It can operate on biofuel for sustainability, so things like biofuel and waste methane, more of a specialty, but can be done. You can fit them with all kinds of nice pollution equipment, and also there's tiers of emissions from generators. The tiers are getting more arduous, and the generator manufacturers, or the engine manufacturers more properly, are putting that stuff and engineering it in with the timing, so you don't even have to have secondary bolt-on to get it done anymore. As far as availability, firmness, and reliability, I'd rather have 200 half-megawatt machines and have 3 fail than 100 megawatt machine and have it fail. So as far as the granularity with the large generating asset, the infrastructure, the lines, the large transformer, you get great granularity and the availability is very high. Monitoring, which we'll discuss, can keep the availability even much higher. And one of the concerns that utilities have, and even facilities, is can I depend on this? How well is it maintained? It's a small generating asset behind the building.